This is lesson number 5. This is our displacement, velocity and acceleration calculus. Okay, so you've probably seen this before. You know this from doing differentiation and integration at higher with graphs, that the rate of change of something is the differentiation. So if you think about speed or velocity is a rate of change of distance or displacement. It is a case of how many extra meters are you adding on per second, kilometers per hour, miles per hour, whatever it may be. It's a rate of change of distance or displacement. Acceleration in turn is again rate of change of speed or velocity. How many meters per second are you adding on in each second to get meters per second squared? Okay. What that allows us to do, first of all, is to prove our equations of motion. So we know that our velocity is our integral of a with respect to t. Okay, that allows us to say, well, v is at plus c. Remember your plus c. Okay, now plus c, if you think about it, a constant value being added on in this context is actually just going to be that initial speed. Okay, so what that means is we can say we get v equals u plus at. Okay, so there's our proof for v equals u plus at. Okay, what we can also say is that we know that displacement is the integral of v with respect to t. Okay, so the integral of u plus at with respect to t. Okay, what that then allows us to say is that s equals ut plus half at squared plus c. C is 0 usually. Okay, and if you think about the way we've done other problems, if c is not 0, we add on the initial displacement if we need to. Okay, so for the purposes of this, we can say that c is 0, and if it's not, we add it on anyway. Okay, so s equals ut plus a half at squared. Okay, so there are the two proofs just to fill in at the start of the set of notes if you haven't managed to do that on your own. Okay, what we're now going to do is just have a quick look at the examples that are there. So example number 1, again, if you continue through your notes, obviously you can pause the video if you're catching up, is that a train moves with velocity is 3 plus 0.2 t. So we're starting to get into variable values rather than just constants for our velocity, displacement and acceleration. Okay, so v equals 3 plus 0.2 t. Okay. What we're asked is how far does it travel between 3 and 5 seconds? Okay, so between 3 and 5 seconds. So this means that we don't have to worry about that plus c, because what we're going to have are limits. Okay, so the displacement is the integral between 3 and 5 of 3 plus 0.2 t with respect to t. What that gives us is 3t plus 0.1 t squared between 3 and 5. Substitute 5 in, 3 5s are 15, t squared is 25, 0.1 times that is 2.5, so 15 plus 2.5. And then sub 3 in, 3 3s are 9, t squared would be 9 again, times 0.1, 0.9. What we have here, 17.5 minus 9.9, so 7.6 meters. Okay, so all we've done there is a nice simple integral problem there with limits, nothing beyond anything you've done before. Okay, it's just about remembering how to use what in the given situation. Okay, example 2, if you turn and have a wee look at that, tells us that a particle has velocity in meters per second, v equals 5 plus 3t squared, with an initial displacement of 10 meters, and what we're asked is what is the displacement of the particle after 6 seconds. Okay, so what we're going to do here is say that, again, displacement is the integral of velocity with respect to t. So in this case, that means we're doing s equals the integral of 5 plus 3t squared. And you're about to see why we didn't put that plus c in the proof when we're looking at this s. Okay, because we're told between in the first 6 seconds, we're still going to have to put limits of 0 and 6 on this, and then also consider the additional 10 later on. Okay. What that gives us is s equals 5t plus t cubed between 0 and 6. Okay. Sub in our 6, we've got 30 plus 216. Sub in our 0 minus 0. So we can say actually that's nice and simple, 246 meters. Okay. Our total is that initial 10 meters we were told about at the start, plus that 246 we've calculated. Nice and simple, 256 meters there. Okay, nothing too complicated in there, nothing you haven't seen before, but worth just getting to grips with it, make sure that it's just automatic. It makes life a lot easier later on in the course.